Okay, sure.
And
So, yeah, as Giorgino said, don't hesitate to cut me off and to ask stuff. That's a live session. That's a lot nicer to speak and to talk about stuff that are a bit weird and stuff. So let's go. So my name is Pierre Misse-Chanabier. I've been a PhD student in the Herme team, so the team that is developing Pharo specifically, for the past 4 years, and now I've been away and I have had a job in Microdoc, which I will present at least for a principle of it after my presentation, or before, as you wish. So I finished my PhD on virtual machine testing, virtual machine, particularly the Slang virtual machine in Pharo. We applied differential testing on the different form of the Pharo VM and compare the result and did some stuff around that topic, basically. And during my PhD, I also did a paper that was completely unrelated on using virtual machine level tooling with language level ordinary object pointer. That title is a mouthful, but I promise that's interesting. At least for me, when I was repeating this morning, I was missing it a lot because unfortunately, there wasn't any interest in it. So I moved on to other projects. And I'm still very proud of what we did with Teo Uliano, which was also a student, a PhD student with the Herme team. So I moved on to a new job, and he moved on to his second kid. So he didn't really have time anymore to do silly stuff on the virtual machine, on the Pharo virtual machine. From a personal side, I'm living in Lille still, so the north of France. I have a cat, a dog, and I still code. Coding is basically my main fun. So I guess that's all about me, and I think we can go on into a presentation then. Particularly, there is a QR code there. This is because this is a presentation that I did for the virtual machine, an interpreter, VML, VA virtual machine implementation and language implementation. I don't know, this is not the right way. Anyway, right, what doesn't matter. So for a workshop that was collocated with Splash, and there is a paper associated if you are interested in looking it over at some point. Very good. So you have a QR code there, and you will have it on the last slide as well. Okay, so I don't know about you guys, but I kind of love having tools. Like if I don't have a tool to do something, I will create it. Let me script everything. Let me script my taxes, my bank. I don't care. Just let me an access to do some stuff. And when we talk about languages, we kind of have two levels at which we have different kind of tooling. So we can tool at the source level. So in Java or Pharo, so for instance, adding a breakpoint somewhere, that's kind of a language level tool. Adding your code through Metacello, through Iceberg, whatever. And you also have the virtual machine level. So in the case of Java, there is a lot of virtual machines, of course. In the case of Pharo, that's Pharo VM, and over distribution will be OpenSportLog VM usually. And I think there is also one with Syncom. I don't remember the name. It's been about, yeah, so I forgot to disclaim first. It's been a year since I've been in any Smalltalk communities. I've been moving on to Java, unfortunately. Graal is nice, but I still miss it. But I don't know some stuff that may have happened in the last year. Okay, sorry. And when you look at sources, source level tooling, you have a lot of stuff. You have debuggers, profilers, compilers, code browser, XUnit, refactoring, project management, and so many more. You have tools for everything. That's mind-boggling, and that's great. I love it. But when you go to the virtual machine level, you have less stuff. Like you can have some debuggers. In the case of Pharo, for instance, they did a debugger to custom debugger to debug their JIT compiler. There are a lot, usually profilers and memory visualization, particularly on the Java side. In the case of Pharo, we also have the Bootstrap. Those kind of stuff are super difficult to write and require a lot of expertise on the specific virtual machine you are doing it on. So that's impossible to do for just a Pharo developer that wants to go into the virtual machine. You will have a lot of trouble. That's a hell of a knowledge gap to go on. And I want to to give you an instance of why that's important to not forget about tooling at the virtual machine level. While I was with the remote team, we had a student that was working on improving the graphical user interface of Pharo. And I don't know about you, but I did exactly what that student did. He put a halt somewhere and said, yeah, we'll see what happens, right? Make it explode so we can see whatever happens, and then we can start to understand stuff. And so he does that. He saves his halt. That's fine. Okay, everything works. He continues working for a couple of hours. Fine. And then he goes to lunch, come back, try to restart his image, and boom, nothing works anymore. He cannot start that image back up. And I mean, that's just well, that's something that we do all the time, everywhere. So anytime that you have an alt somewhere, if you do it in the sensitive part of your Smalltalk system, you may have some breaks like that. I don't know if it happened to you, but it certainly happened to me. I touch the compiler way too much, but that's another topic. And so he was using the Pharo launcher in that case, so he wasn't seeing what the error was, but he asked for some help, and I just said, come by and we will check it out. And first thing first, trying to look at the console, right? So we launched it from the console, and you can see exactly the method that I displayed right before, the alt, that is trigger, the alt, and it just waits. That's an alt. That's what an alt does. It waits for user input, but the user cannot give you input, give input to that alt because it's stuck. The thing is that specific method is used during the Pharo startup, and therefore it's try to start up the graphical user interface, gets on that alt and wait. So that's actually expected behavior. Not great, but I mean that's expected, right? And the thing is that you cannot start the language in that case. And if you cannot start the language, you cannot fix it with a language level tool. And that's why we need VM support for those kind of stuff. So let's check out how to code VM level tools. So the first thing that we would tend to do is to try to find the class form, to find the method that is with the alt and rewrite it somehow, right? And the thing is that we have a memory snapshot. Our memory, the whole memory that we use during our Smalltalk development is a snapshot and contains everything that we need, right? And you can input it to the production Smalltalk VM that works, except when you have those kind of errors. However, when you input it to the simulated Pharo VM, which is the way that the Pharo VM is developed in itself, it's developed in Pharo itself, basically, you can try to load it and check it out. And that's what we will need to do. So just for the principle of it, is this the class form for you? That's just the snapshot that we opened with a text editor, so a binary representation. And we just find that string form somewhere. Is that it? No, of course not. That's the string that represents the name of the class form. And can you find the class form here? I don't want to try. To be honest, that's too much for me. I'm not brave enough, clearly. And before we can continue any further, I need to give you a small amount of context on how the VM encodes objects. That's what's called an ordinary object pointer, an OOP. You will hear me say that a lot during this presentation. An OOP is just a bunch of memory, like you would have in C. You allocate a bunch of void memory, and the VM puts a header at the start, describing what is inside the rest of that bunch of memory. Okay. And so therefore you have a header, and then you have into the slots references to other objects. Sorry, to other OOPs, which are objects. This is just a different representation. And to exemplify again the kind of OOPs that we may have to deal with, the most complicated one is the compile method OOP. So with Vicha's header, so this is nice. You is describing the method and whatever is inside it. But actually, compile method have an extra header, which is not an OP. Then you have two literals, which is the literals from the compile methods lingo, let's say, which can be OOPs or small talk literals like integers. You don't know. And then you have bytecodes, but bytecodes are not an OP again. These are 8 bytes, which contain each of them a bytecode. But do you know the order? Do you know which one is the last? Do you know? Do I have 1, 4, 6 bytecodes in it, or 8? I don't know. The point here is that if you try to look at an OOP, a random OOP, and to try to iterate over it, you will have a lot of trouble. This is complicated because the form that we need to use to encode objects are not trivial. But that's what an OOP is. Okay, with that amount of context, we will. This is code that you could input in the simulator, basically, and that should be able to find you a class that with a particular name. So in that case, particularly, we want to find the class form. And actually, spoiler alert, this gives you this number. This is the address of the OOP. So yeah, I need to absolutely to do that. So that's 406 million. I don't, this is too big for me. I always forget how to read past 5 numbers. That's too much. But this is the address. And you have to remember it and to manipulate it to do some stuff at the VM level. So let's go through that method line by line so I can highlight the difficulties that you will have to face. So first, the term variables, I think that everyone knows that we are not in a Java conference, so that should be fine. Then, more interestingly, you have a memory class table entries do. This is because the memory at the VM level uses a class table that's very simple, a class table that knows every classes that are installed in the system. Everyone, even the anonymous one that you may create during metaprogramming. And either you know that specific object exists, that class table exists, or you don't, and you will have trouble finding it. But we can iterate over it, so that's already pretty good, actually. From that class, we need to find the class index for a particular OOP. So this depends on whether this is a meta class or not. You have to know that again. You have to find out whether that class OOP is a meta class or a class site, or an instance site, or if that's a weird shaped class, that can happen also. So that's a bit more difficult. I'm adding a lot of complexity in those methods. Next, we have to fetch the part of this class OOP that is the class name OOP. Okay, so at in some slot of that specific class OOP, we have the string name that represents its name. But that's still an OOP, so we have to convert that string OOP to a string object, so we can finally compare it with our initial class name that was provided as argument. If that is the case, then we found our class OOP, which is the case there. And if not, we return nil OOP. One remark before the next slide is that, do you know the difference between... Sorry, yes?
Sorry to interrupt.
Yeah,
just to understand, so here you're showing the class of the VM simulator. So all this code is to find the address of a class.
Yeah.
But will this be translated to slang or to C
That's
code,
a good question, actually. I just want to finish that point. Memory Nilo, I don't know the difference between the address of Nilo OP and that address there. That's just what I wanted to finish before. Because these are big numbers, either you know the value of Nilo OP or you don't, and you have to check it out. Okay. So, about this code is, you could say that if you were implementing these two methods, that would work on a simulator. It could translate, actually. This one could translate to C code. you would have a need. You would have to need to have a need to do it, but that could be possible. That's the thing with Slang is that it's converting only what it needs. So if it finds out that this method is never called, it will not use it. But yeah, but that could be something that you may have in C. So through FFI or other stuff afterwards. Does that answer your question, Gio?
Yeah, thank you.
Okay. I hope that I'm not going too fast because I tend to work to talk a bit fast. Okay. So the things that we saw in that specific slide that was a bit cumbersome is that first we have VM level hidden OOPs, hidden entities. So you need to know about them, that they exist. This is a low level style. You don't really have a receiver, you don't really have polymorphism, at least not for those kind of stuff. And therefore you need to use a more procedural, functional kind of coding. So that's a bit weird for us that are pure object-oriented developers. So that's also an OP-based API. No, that's what I say here. This is low level in the sense, sorry, that you are manipulating memory there. You are manipulating chunk of memory, and you have to do pointer offsets, and that's really something that we don't do in Pharo or in Smalltalk in general, as far as I know. And of course, we have to deal with OOPs. So again, is that nil object or is that the class form that we found, right? You have to look at memory nil OOP to compare it to see whether that's the case or not after you run your code. So you have a lot of checks to do. So to recap, the knowledge gaps that we encounter when we try to work at the VM level are first the ordinary object pointers, which are different from the kinds of entities that we work with at the language level. The API manipulating OOPs, which is not polymorphic, this is just a bunch of methods. You have to go through 100, 200 methods sometimes to find the one that you need. And it's not always consistent because this is a big API, big work over 20, 30 years. So of course there are inconsistencies. And this is also VM level information that you need to know. That's a gap. You have to know about it. That's it. So that's really complicated to get into it. And the solution that we propose is LLOOPs, so language level OOPs. The idea there is to have language level entities rather than simple ordinary object pointers. So to work with the same kind of objects that you would work at the language level. We propose to identify and type all the OOPs, all the memory, which would allow us to have some kind of polymorphism that gets into it and a few more stuff that we will see. And finally, we mix the VM and language level information. That's kind of an equilibrium to find. That depends on whatever you need. That's really an implementation detail. You have to decide which part you show, which part you don't, basically. And to do that, so I said that we want to identify our VOOPs to give them class. So first problem that we encounter is how to look at these OOPs. How can I find all VOOPs inside the memory? And the VM does that a lot, particularly during garbage collection. And the principle is quite simple. You have an OOP, the first one. You look at its size, and you just jump over it when you want to get to the next OOP. And you repeat that until you are at the end of the memory. That means that everything in the memory that is managed by the VM is an OOP. There is not one weird thing somewhere that is not an OOP. Everything is an OOP. We will see why that matters in a few minutes. So now that we know that we can see which we can cut down our memory to say, oh, there is an OP there, another one there, etc. We can ask what there are. And the algorithm is actually quite simple. Is it something very specific? I propose a class there. I don't remember whether that's the most specific one, whether that's a meta class, whether that's a free object. So a bunch of memory that is at this time unallocated, because as I said, everything is an OP. Is it something else? Or if there is absolutely anything specific about this object. That's just an instance of something else. So that's how we type it. And we find there that this is a class, a meta class, an instance object, and a free object. And we propose an identified memory, which says, I know exactly where all of these OOPs are, and I know their types. And instead of tooling directly the memory that is cumbersome, try to create your tools on on this identified memory, so it's easier to manipulate. That's the basic principle of what we propose. Very basically. And now that we have this, we can try to write tools, to write small stuff. So the first one is to say, I want all the classes, right? That's something that we can do pretty easily because that's just exactly what we have at the end. So I check all of the objects, I collect everyone that is a class, and that's it. I can ask for a verified metaclass, so identified metaclass if you prefer. That's because we actually needed metaclass a lot during our development, so we just put it somewhere. And we can ask a bit more interesting stuff. So like all classes OP, I want to get only the class side of these classes, this classes OP. And even the thing, at some point we were kind of getting stupid and we were bored, and we were writing our PhD with Theo actually, so we needed to have some fun and to do some stupid stuff on the VM, and we just wanted to try whether we could decompile it, right? We have this OP, we know that's a compile method, and we have all of the object graph. Can we decompile it, right? And if it doesn't, if there is any kind of error, we don't care, just return nil. That's not the point of this experiment. And in maybe an hour or two, we were able to decompile 80%, I think, 90% of the VM, of the Pharo image. So that was pretty interesting. There was a compile method is very weird, was very weird, at least at the time. And we still had pretty good results. So we were pretty happy about them. Okay. So that is a base, actually. This is just basic tools. Now I want to do a little bit more small talk stuff, right? I want inspectors. I have inspector for every object in my Pharo image. I want to have specific inspector for that as well. So that's what we did. And you can see here particularly the mixing of the two levels, right? We have VM level information, particularly the address, the header when we need it. We have the OP class tag, so that's the index in the class table, very basically. We have what is the hash, the if, whether it's spin, where it is in memory, because there's multiple space that are managed by the Pharo VM. If you didn't know, there is a young and old space, and stuff like that. And we also have language level information. Particularly, we can ask for the print string there. We have the name of the class directly. We have the format, so the selector even, because this is a compile method. And even if you check it out, actually, selector, method class, num literal, and num bytecode are attributes name, in the instance variable names. So yeah.
Sorry, interrupt again. And
No,
maybe
go.
it's
No
the
way.
same question. So here you are saying, so we have the VM simulator,
Yeah.
right, where everything executes at a level which is bytes and OPs and very, very low level stuff that then will be what the VM executes.
Mhm.
And you're saying if you want to interact with that VM simulator is a very, how you say, unfriendly, because so you build a lot of tooling to more easily see what's going on. But all that tooling is just to run the VM simulator. It's not going to be affecting the generated code of the VM. Okay, that's
one of the objectives actually that we had was to keep ourselves completely outside of the VM code. We didn't want to touch anything, to change anything in the VM code, because we had no control over it. And actually, that the presentation, the live presentation, will be a bit weird because They changed a lot of stuff. They made breaking change at the language level and at the VM level, and this is complicated to install now because it's been a year. I haven't just allocated on some of it. But the question also that you kind of have in the background that goes back to what Gio asked earlier, whether that's translatable to by slang to C code, is I don't know. The idea there was to try out to do some stuff, and we just went a bit further than we initially planned. But in theory, there is nothing that would prevent you to do exactly that at the C virtual machine level. It's just that, or even translatable in a translatable manner. That's just a matter of time, right? So these tools could be implemented with the same schema or not at the VM level. Does that answer your question, Francisco?
Not sure if I understood all what you said, but yeah, carry on with the presentation. Sorry.
No, but do you want to try to reformulate it so I can try to to answer properly?
I didn't understand what you said about if you don't know all that. So you did all this work. I got the idea that it's not only your work, but some other people, and you don't know if they are going to be continue working on that or not. Or okay, right. So then, yes, you answer my question.
Okay. Just so I can answer that little bit more. That work was done with Theo Rogliano, so that was doing his PhD as well. And that's it. We were only two, and that was it. The VM team in the Hermod team wasn't interested in that, so that's okay.
The VM team in where? In
Hermod team. So that's Guichet,
okay.
Polito, Pablo. I forgot the name. Sorry.
Hernan, maybe.
Pablo Tedos Tesone, and there was Esteban. I don't know if Esteban was. Maybe Esteban didn't work too much on the VM lately. I don't remember. But at least Guichet and Pablo weren't interested. But was it?
Okay.
I guess it begs the question: did they have other tools that they used to figure stuff out?
Again, I was writing the PhD thesis.
That's where the mismatch sometimes lies. Yeah, I mean, some things stick, some things don't. Some things their times before people realize, right? So yeah, it's
So I did my part. Presented that everywhere. They weren't interested because they use other things, I guess. But in the last 6-9 months of my PhD, I wasn't working much on the VM anymore, at least not with them. I was doing my small stuff to blow off steam while writing the PhD. So
that makes sense.
Yeah, they changed a lot of stuff that they did, and I just didn't watch it. Right.
I'm sorry. So the work that you're doing now in Microdoc has nothing to do with this. Or...
No, nothing. Okay. Yeah. Nothing at all. I will talk a bit about it afterwards, but yeah.
Anyway, let's keep going. So I think we're slowly starting to understand what you're telling us. I think.
I hope that it's kind of manageable. That's still low level stuff.
No, it's a little bit of a mind messer. This one, it's like okay.
Yeah, I know. That's for me. That's so, you know when you have your head so deep inside your work, it's easy. Come on, that's just physics. No. That's never easy. But yeah, I'm too deep into it. For me, that's become kind of easy. I still hope that's kind of manageable. Okay. So I think we were done on this. So yeah, what I was saying right before, so we can get back into it, was that we have different information, language level and VM level information in this inspector, and particularly one thing that I thought was interesting is that the selector method class num literal num bytecode here are instance variable names. So this is meta information that is stored inside the class that we retrieve and put back together with the value of that particular instance variable. That doesn't seem like much because you kind of have this at the language level by default, right? That's so basic. But we kind of were recreating a way to look inside it. So that's the first kind of tool that we did. And that's something that is not trivial at the VM level either. Okay. So we have inspector for stuff now. And because I'm very stupid and I want to do weird stuff and I love to look at inside stuff, I try to do memory visualization. What's inside that specific image, right? In a more global way. I don't need to know the details. Just show me the gist of it. And that's an image. Each case inside that table is exactly one OOP. So that's a header with stuff. That's it. And this particular image is about 2,500 or 3,000 objects, I think. That's on the right side there. Just a small highlight. This was work done by Karina Hernandez during her PhD in the remote team, which was trying to create very small Pharo images or Pharo-like images that were run onto the Pharo VM without touching the VM at all. And this particular image was about 70 kilobytes, I think. And she was able to do a 70 kilobyte image, which is more readable for us right now. So that's pretty good. And the first thing that we see is that there are regular objects at the start of the memory. So just so you know, it's nil false true, I think, which are a singleton kind of. That's we have 5 special objects. So VM level objects that are known by the VM but not displayed to the user. We have 3 more regular objects. We have compile methods after that, classes after that, and finally regular object before more compile method, more regular objects. And at the end, of course, we have a context. So the first method that will be called basically when the image starts. What is that? That's a pinned object, so we will talk about it in a minute. And a free chunk, so that's the rest of the memory. Basically, there is a very big OP that says the amount of memory that is left to be used. And that small graph allows us to kind of see what Carolina has been doing, because she was trying to explain to me a while back that the bootstrap was achieved in 3 phases of allocating a bunch of objects, putting them in memory, then rerunning stuff, and I didn't really get it. But actually, we can see it now. We have a lot of objects that are, we put compile method, but we put them in no classes because we're instantiating them before the classes. So classes don't exist, therefore they are not in the classes. So we can see that first phase here of allocating a bunch of compile method, bunch of classes, and filling up and putting all the links between all of them, right? And we can see a second phase where we compile a lot more method, which need apparently few liters, and over regular object that is probably for those compile method. And finally, to do the context. So we need to do all 3 phases of the bootstrap to get to that point. And that was kind of nice to see, to be able to see it in a dense graph, basically. Just for reference, I will show you a minimal Pharo image later. That's about 7 megabytes. That's a lot less readable. So enjoy that one. That one is cute. I prefer that one a lot to show people. And so the next thing that we did was we want to know whether she did a good job. So did she do a very small image? And if she did not, why? So there is these 2 possibilities there. Either she has a lot of unused objects that are very small. That's first kind of waste. Or she has very big objects. And if we just scale each square by its size, well, we get that. So actually what we see is that we have 4 very big objects, particularly 1 humongous object and 3 big objects. And the rest is pretty much nothing in comparison of those, right? And so we started to check it out. What are those stuff? And the first thing that we see is that this is pink. Pink, if you remember, is special object only known by the VM. And actually, the humongous one is the class table. This is the OPs that references all of the class table pages, actually, which are the 2 next one. And its size is 4,000 slots. And each class table page is 1,000 slots. If you remember also, there are 51 classes and 51 meta classes, so that's about 100 classes, and we have 2000 slots to store that. That sounds like a lot of waste. And that's due to the constraint that Carolina had during her work, which was to not touch the VM. And in the Pharo VM, there is a hard-coded literal somewhere that says the class table is this size. And we assume everything based on this size of class table and class table page. So that's why, if you want to improve on Carolina's work, if you want to do more bootstrap stuff there, you probably need to check that out. That's where you can get smaller images. That's the very limiting factor there. And another thing which is less easy to evaluate there is the remember set. So that's black because this is a pinned object, an object that does not move. This is due to the fact that the remember set is a kind of object that is used during garbage collection. And whether that's big or not depends on what you are doing with that small image. So we could check it out, experimentally, find whether we need to get it bigger or smaller, but that's experimental, right? The class table page are a bit more obvious because you do not need 4,000 slots for the class table in that specific case. So that's one thing that could be done to improve our work. And I thought, and just scaling by the size of each box was very quick. So we can get an evaluation of our work in a few minutes. So that was pretty nice. And actually, that's that same image again. So the candle, basic candle Pharo Pharo candle image. I don't remember exactly how she named it. And there is a specific object which is called the special object array that you may have heard of, because this is kind of exposed on the language side, but you shouldn't really touch it because this is super sensitive. And it should be there. Actually, if we just select the OOPs that are 60 slots, which is exactly the number of slots of the special object array, it's there. It exists. It's fine. But the VM actually says that the special object array is there. So this is not at the place it should be. And why does that matter? It's because this object shouldn't be garbage collected at all, ever. That's why it's in the start of the memory, because the start of the memory is never went over during garbage collection. The garbage collection doesn't touch this object at all. So that means that if you're using Candle and you have a garbage collection that breaks everything, that could be related. We didn't fix it. I checked it out quickly, but that was more complicated than what I hoped. And therefore, this is duplicated, will be garbage collected, and yeah, that's not a good bug. But we reported it to Carolina and to Pablo and people that were managing that. So maybe they will fix it. I don't know whether our work was taken back by someone else. So at this point, but that was pretty nice to find. Because the thing that we did there was just naming stuff. We named our objects and we checked whether they were normal. So we checked that slot and that wasn't the special object array, and we say, oh, damn, that should be the special object array. So from that kind of small tooling, we can get very interesting stuff. A second kind there of memory visualization that you should be very used to by now is a class browser. Right. In every Smalltalk distribution, the first thing that you implement, or almost the first thing, is the class browser. You want to be able to find your class, to browse your classes, and to check your methods. That's important. That's basic. And the thing is that you may remember that form, scale by display, scale factor is a method that you know about, because we kind of talked about it at the start of this presentation. And that's our first real-world application of what to use Polyphemus for, which is a meta error. So an error that is in the environment and triggers more environment issues. So that's usually the GUI, the debugger. If you try to debug the debugger, that can get pretty fun. If you try to debug the compiler or do stuff with the compiler or the parser, stuff like that, basically. And therefore, so we get that student and we started investigating. And we find that form class in about 30 seconds, because I did the class browser before. That was very easy. And then we have our stuff. And we check it out. We compare with the regular Pharo image, so we can see exactly the difference that there is. And what we can see is that there are 3 extra bytecode, 16, again 13, and the literal alt that is in first position. And to be very precise, if you want to see there is an offset of 1 for a few bytecodes there, that's because of the index of the literal that's changing. But what we did was simply to remove those first 3 bytecode. We remove the literal, and we try to restart. We modify the binary form directly. We try to reuse it in the production Pharo VM, and poof, that student recovered 2-3 days of work because he didn't save for a while, and he was pretty happy. And we were too, because the thing is that to get that result, it took us about an hour. And the thing is that the longest part of that hour was to load the Pharo images inside the simulator. It took me maybe 2-3 minutes to fix it. Just because I had the right kind of abstraction, not even tooling. The tooling wasn't ready yet. The tooling to modify method is not ready at all. But I had enough abstraction to be able to do stuff without that much required knowledge, actually. And that's the part that is interesting for me. Okay. And the second real-world bug fix application that I can present there is how to deal with memory corruption. So you may remember that I said earlier that we use only OOPs everywhere inside the memory. There are only OOPs, but actually, if you flip 1 bit, you have an object that doesn't make sense anymore, and then you cannot iterate as I showed you earlier, right? You cannot just check an OOP, find the byte size, shift the pointer of the size of that OOP, and continue, because that OOP doesn't make sense, and therefore, what happens is that after that point, you have a memory that you cannot deal with, not in the simulator, not in any kind of way at this time. I have no idea how Pablo or Guichet, I don't even remember how they deal with memory corruption. I think they just throw away the image and say, okay, until we have a reproducible case, that will be okay. That doesn't matter. And that's a very sensitive way to look at it, because I don't know how much you know about memory corruption, particularly in a language like Pharo. But this is hellish to debug. These are stuff that are non-reproducible, that you cannot really see happening. Elliot Miranda, so the developer of OpenSmallTalk VM, has actually a pretty nice paper explaining lemming debugging. If you are interested, just ping me at some point. I will link it to you. I think that was pretty interesting to me. But to try to give you a comparison, a real-life comparison, imagine try to solve a crime where the crime happened a century ago. Everything was washed. Multiple families lived there for a while, and another murder happened in the meantime. And we trying to solve the first one. That's the thing that you want to find. But there is so much stuff that happened after that point that coming back to the source of the bug is extremely difficult for VM developers. That's a nightmare to them. So just throwing the image away is probably the most sensible thing that they can do, to be honest. And so again, we were bored with our PhD thesis. We didn't want to write, and we wanted to play with corruption, because what is a nightmare of someone is a pretty good fun for someone else. And the first scheme that we tried to apply, which was actually pretty good, and we didn't really, I think there was another scheme, but we didn't document it, was to simply try to iterate the object graph rather than the memory. Instead, since at this time in Polyphemus we have verified object, we can just take all the first OOPs that we discovered until the first corruption, because there might be more, And we just look at the object. So we look at each slot of each object. We try, okay, we can isolate kind of corruption. So if I try to access the first, the OP in slot 1, I get on the corrupted one, so I just stop my path there, but I can continue in slot 2, therefore I can isolate that corruption to a smaller amount of memory. And after a while, we kind of have isolated all the corruption, and we have recovered most of the memory. So instead of having just all of that memory on the all of that wasn't readable anymore, we have recovered pretty much everything. And after that, the only thing left is cleansing the memory. We remove it. We say, okay, this part of the memory doesn't make sense anymore. That's kind of sad. You may have lost some work there, but we cannot do anything about it. However, we can make it so it's valid memory by saying that it's free. Now we say that object is free and you can reuse it and you can try to restart. So therefore, even if you don't exactly, you may lose some stuff, some coherency, some consistency, but you get to a point where you can restart the Pharo image inside Pharo, in the Pharo VM, in the production environment, and try to fix whatever is back, rather than just throw it away directly and just say, this is done, this is garbage now. And we were able to recover an image like that. The corrupted objects that we had were not crucial. Like it didn't touch anything too deep inside the runtime, and therefore we could restart the image and recover the work that was lost. So in that case, it took us more time, of course, but the student was gone, but that worked. And that could be helpful to debug memory corruption, but again, PhD, and at some point we had to stop. So we didn't get to the root of the bug. We couldn't work on it further. I hope that they found it by now. And so I want to analyze a bit of what was useful there, and particularly the two main things are object slot iteration. So since we had abstraction, we didn't have to look at the method again and say, oh, this is an OP, this is not an OP. Okay, I can switch to that index, to that. We just said, okay, iterate over all of the OPs in that object, whichever they are, wherever they are, and we can try to do stuff with that. Everything that is not an OP doesn't matter at this point, so whatever. And the second thing is reference patching. So when we isolate the corruption and we can say, oh, this part there is corrupted, we can also overwrite it. And that was very easy because we have isolated to a small part. And that's mainly these two abstractions there allowed us to focus on really how to deal with the corruption. What can we do with the corruption rather than to wonder how to deal with how can I access this part of the OP, but how can I check that its integrity is intact? That was where. So we were able to focus on that thanks to Polyphemus. So to recap, that was a bit dense. I know, I hope that was okay to follow, but we will see that a bit more. But basically, tooling at the VM level is very difficult. In any language that I tried to work with, tooling at the VM level is difficult. We try to bridge the knowledge gaps that are required to work at the VM level by providing language level entities, in the case of Pharo objects that proxy OOPs. We try to do that also by identifying and typing OOPs, which helps us develop in a more OOP manner that makes more sense for a Pharo developer, and to mix language and VM level information. So we can, for example, one thing that I didn't really talk about is that actually you can see all the names there, but to find all the names, you need to find all the string classes. There is not one. There is string, there is byte string, white string, and two other in the byte symbols and white symbols, right? You have to find all of them. You have to know how to find them. And that part was like one of the most difficult things that we did aside from the corruption. We need to get to that point of abstraction that we provide with Polyphemus. You have a lot of small details to know, and that is the difficult part. So there is my address there, pierremisse@msn.com. That's an old one. I'm mostly on Discord. Basically, if you want to get in touch with me at any point, talk to me on Discord. I will answer in an hour max. I have my GitHub where you have a lot of stuff, and the paper QR code there, the GitHub QR code there. Where I left it there. Yes, we have Polyphemus that we will see in Pharo in a minute with the full repository there. The build is failing because, as I said, there were breaking change on the Pharo side that we didn't really work with. And there were some people from Thales that work on Pharo that tried to load the Pharo image, but again, we broke everything for them, but we didn't hear from their back, so that was okay. Do you have any question on that, Ben? More questions, Evan?
I do have one more question. Okay, sorry. Go ahead, Tim. Or...
I was going to ask, so these tools, I didn't quite understand how you load them or write them. Like, are they text files or something? Like, are you loading up the simulator and then like you've got a text file and you write these pseudo things, or?
Yeah, actually that's it. That's what I was trying to explain there, but I may have gone too quickly on this. This is only on the simulated Pharo VM. We run we put everything in the simulated Pharo VM. This is a layer on top of the simulator, and you write your tools on that layer.
My question was going to be around that same. So this approach is only possible in the Pharo VM. So if you have any other VM, like a C VM or a Smalltalk VM developed in C, obviously you cannot do all of this. So.
You can.
Oh, really? Okay.
Oh, yeah. That's very... no, that's very... What I'm trying to say there is really the abstract concept of identifying your memory rather than just say, okay, this is memory and I don't care. And to let the VM says whatever it wants to say with it.
So you're basically saying, you have a set of Smalltalk objects that are able to read raw memories, like a big byte array, and it makes sense as if it were a virtual machine written in C, and then you have to build all the logic to be able to navigate the pointers.
Exactly. Okay. So you could do that in C. Actually, we there's two small anecdotes there. I wanted to do it for C exactly, to redevelop GDB. Never got to it, but that was kind of one idea that I wanted to try out because I'm pretty sure that it's doable, not easily, but that's doable. And the second one is that actually Theo wanted initially, the first thing that Theo wanted to do was to try to connect to an active Pharo process and identify the memory live. And to be able to interact with the memory that was actually running. To monitor it, to do stuff with it, to modify it, to inject stuff in it. And yeah, that was too much. But he got actually some pretty good pointers. He could have gone, I think he could have made it, but just it required too much time, and that was way more complicated. And we needed the base actually. Without the base, you cannot write any tool. So I forced him to drop it.
I got a question, if I may. So could you tell us a bit more about the interaction you had with the people who worked on the Pharo VM? So you go along to this thing and say, we can look at a saved image and we can perform an analysis of it, and we can do all these things. How did that conversation go?
So when I was doing that, I did the VMEL presentation. I also did a poster for poster presentation to try to show it to others in RIA team, and I just show them, and they asked 2 questions, and that was it. From one look, they weren't interested. Yeah,
it's a bit disappointing because it seems you've built up a catalog of what's going on in the memory. And I imagine you could take this and then build all kinds of interesting analysis of what's happening there and look at the efficiencies and stuff.
I know. That's the thing. To be honest, I didn't want to pursue my career in research at all initially. And then we developed this, and I was like, why did I start my PhD 2 years after I started? right? If I had this, there is so much stuff to do with this. We had so many ideas. I mean, we still have them. Every time that we find something that is weird, we are like, yeah, but we could solve it with Polyphemus if we were going that way. And yeah, nobody was interested in it, so that was it. And actually, if you are interested, at some point, I will talk about Microdoc in a minute, but we propose Microdoc management agreed to allow me to offer support for Polyphemus if someone is interested to buy it. But yeah, that's an industrial thing then. But yeah. The discussion with Pablo and Guicho about it were pretty minimal. They just wanted me to finish my PhD, basically. Stop looking elsewhere, focus on the PhD. Stop playing with a VM. So that wasn't the time, that's true, but I needed to do something. So.
Did you finish your PhD?
Yes.
Yay.
Yeah.
Congratulations. Yeah.
Yeah, very
Thank
well.
you.
Yeah.
To be honest, I would prefer still doing that. Yeah. Theo didn't. I dropped it.
Just to go back to what you were trying to explain to me. So if you're running on top of the simulator, does that mean so then you've got like all of the Pharo language and tools available to you, but what you're doing is using those Pharo objects and methods, but you're operating on oops and chunks of memory. So if you want to know the size of something, you can you can get the size of a bytes or something, and so you're building everything that way. Yeah. Gotcha. And so the visualization you can use whatever graphic library, you could use Rosal or something, because you could do that bit in Pharo, but you're just getting the information from the processing of the oops and
the simulator. Right. Yes. That's actually what I tried to highlight there. With the decompile here is the Pharo decompiler. We didn't implement one. We just tried to use the tool that were available.
But you gave it the bytes that you'd collected
one thing that might be important to realize also, because actually I should have made that clearer. What we are looking at here is static Pharo image. So a Pharo image that is not running, that is just loaded inside. So you do not do reflexivity inside your own bytes. Can't do that for very obvious reason. Right, at least me. But so there are two different images that we'll use there. And the one that is hosting the static one has all its tools. So you could use Russell. That's actually what we did there.
Gotcha.
Oh no. Oh yes. That's a Pharo minimal image. That's 7 megabytes of memory. So yeah, look, that's beautiful, right?
It's interesting though, isn't it? Yeah.
I have a question about that small image.
Sure.
It's a headless image, I guess, right?
Yeah. Yes. 70 kilobytes is headless. Yes.
Yes, and it's Pharo 11, or what's the base?
Oh no, sorry, that's Pharo Candle.
Yes.
Pharo Candle is a project that was achieved by Carolina Hernandez based on the work of Guillermo Polito during their PhDs, that aimed at looking at the Pharo bootstrap and see what was doable with it. And they tried to propose different programming languages that would run on the Pharo VM, but that wouldn't be really Pharo. So in the case of, actually, that's kind of a good question. Okay, so this crashed because actually that was kind of fun, because at the time we were doing this, there was what was his name? Mikalion. Someone, I'm really sorry if he hears me someday. I don't remember your name because I still love you. That was, but I can't remember your name. That was working on Russell and improving Russell in general. And the thing is that the images that we open are way too much objects for Russell to handle. and we kind of crash Russell with a simple Pharo image. So sometimes it just crashes because this is too big. Okay, so in the case of this is this one. So if we look at the Pharo Candle class browser, because that's what we are looking at now, we have object, true, false, so Boolean basically. I think you have also some kind of collection, yes, array, word array, byte array, semaphores, linked list. See, that's pretty minimal in the sense
Can you yeah, your camera dropped, by the way. But can you give us a reference to where to?
Of course.
Yeah, because I want to try to open this thing here.
Oh, sorry, your reference to what then? To the Carolina or Polyphemus? Or both, actually?
The one for the minimal, for the small image, and a follow-up question to that. Sorry if it's a little.
Oh no, not at all. But actually, I will just take notes.
Just to cut in, Francesco, if you remember the, Eric on Bike that did the Code Paradise. He uses those candle images, but he's built.
Yes, actually, yes.
He built a slightly larger image to do, to have an image in a browser, right? So.
Yeah. I try to
which again, you could use the tools. You could use the tools to visualize what that image looked like, couldn't you? It's like your
exactly.
Point,
and that was one of our things, is that the thing is with those kind of images is that you didn't see compiler anywhere there, right? There is no parser, there is no compiler. Once that image is created, this is done. That's it. And for Code Paradise, that's exactly the same thing. Once the image is created, that's done. And the thing is that actually you could modify it. You could add stuff onto it or remove stuff if you were able to manipulate them. But images there are just stuff that you can provide to the Pharo VM, that's it. And instead of so that what I'm trying to say is that you do not have to recompute all of that every single time when you generate a lot of images. You could just run them, just increase them in size. So that's something. So
right, and how these images can be like if use kind of a kernel that you can load the libraries on top of that, and
no. As I said, everything is once it's generated, that's it.
Okay,
if you want to add stuff, yes, that I don't know. That was what I was about
you
to
choose,
say.
Right?
Yeah, exactly. But I think that Carolina, I mean, that was a PhD, right? So that was very limited time. To get to Candle, she took a while already, and for her PhD validation, I think that she created 5 languages. Like a Pharo Candle. So Pharo Candle, a very minimal thing that looks kind of like Pharo. There was also Lisp, some kind of Lisp of meta-object implementation, a meta-object protocol implementation, and there were a few one. But what I'm trying to say that I don't think there were libraries that you can add on top of it, because the work was stopped at this point. Basically.
Because the work was what?
Stopped. Because when she just left the team after her PhD, and she finished and she just worked on other stuff. And nobody has taken her place back afterward.
I think Eric's image that he built on top, I think it has the compiler in it, because you can shift stuff down to the image, but it was still a very cut down version compared to Pharo.
Yeah, but that's very sensitive for for example, I deployed the Pharo server literally a week ago. I would prefer to not have to deploy the full image there.
Yeah.
Exactly. No, that's precisely the use case, Pierre, that I'm asking.
Exactly. For me, that's when I was trying to pitch this to people. The main thing that is kind of how do you say it? That is trendy is microservices. Microservices with Graal images are every fucking where, right?
Right, but it's not just because it's trendy. There are very good reasons. It's a small footprint. It's a cheaper. It's a less expensive cloud.
Yeah, exactly. Can
you tell us a little more on how you built this little image of web service that you mentioned?
Oh, I didn't build a small image. I still have a big one.
That's Carolina's work, is what he's saying.
That you were saying that you wished.
Yeah. Maybe I will get to it, but
all right.
I can show you. I mean, it's not really in position, but that was just a website. Quickly, that was a website for a game.
Nice.
So that's a React application, and that I have a REST. Where is it? I use this code. I mean, I don't care about that. Okay, so this is just a web service that gives me those kind of those things. So I get the URL and stuff. That's just a REST service.
Right. You are using Pharo in the backend. Cool.
Yeah. Because I tried to do that in Java, and 2 seconds in, I was like, no, I don't want to, please.
Yeah, no, and it's fine. It's fine.
Yeah. No, Pharo is great for many things, so I still love
it.
Very,
very competitive. Yeah, of course.
Yeah.
Was that thing that you just show your hobby project, or was it your work project?
Oh, no, this is a home project. I just do that on my spare time, and I will publish it for a World of Warcraft player within the week.
It's like a table game, something like that?
No, World of Warcraft is the...
World of Warcraft.
Yeah.
Okay.
Okay, you know this one? I mean, that's kind of famous. Yeah.
All right.
Maybe I give a little background on this stuff. To my knowledge, what was done in Pharo was initially Pharo was a fork of Squeak for reasons, but it always was, let's say, handled initially like in Squeak, okay, with changes and so on. But the idea was then, okay, how can we bootstrap Smalltalk image?
Yeah.
Because when you bootstrap the Smalltalk image, you for sure have no objects inside of the image that are not used, or that you would be in control of what is inside of an image. And there was a work from Guillermo Polito, and to my knowledge, there's also a paper on that one that was called the Pharo Bootstrap.
Yeah.
Pharo Bootstrap was an own project on GitHub there initially, and later it was included in Pharo itself. And since Pharo 7, 8, Pharo image could be bootstrapped, or is bootstrapped. It means every time you do a change or something gets merged into the source code, the image could be built in full. So you have a full set. And this image is used to build the standard Pharo image up now to Pharo 12, which is at the moment in pipe. You could use that Pharo bootstrap yourself to also bootstrap an own Smalltalk kind of thing. So an own image with own informations. And this was approved or done with this Pharo candle as an example. Caroline, to say, okay, to my knowledge, this goes back to MicroSqueak from John Maloney image, and this Pharo candle has around 50 classes, and in that back then there were tools to do that. There even was a UI, a user interface. And it was initially in Pharo, so you could let's say have your source code and control what is inside of your image. The problem with that one was that these tools back then had been written in the previous UI framework in Spec 1, but now Pharo changed to Spec 2, and I think it was too much work to redo it, or say the focus has shifted to other things because it's always a thing of capacity and time. But all of that is available. So even in the current Pharo, you have the Pharo Bootstrap. There's a folder there. And you could use that Pharo candle. Later, then people like Eric on Bike, for instance, came and said, okay, hey, this is cool. I can use that one to build my own image. He used that to bootstrap his own image called Code Paradise and his own system. And Code Paradise is a very tiny image, also not as tiny as the Pharo candle, but a tiny image that could be controlled. That he runs inside of a browser, inside of an HTML page, for instance, and he uses this Squeak.js from Vanessa Freudenberg. So this is a Pharo VM, the Pharo VM, a Squeak VM written in JavaScript, and because the image is compatible, you can use any of these images that you, let's say, bootstrap with Pharo Bootstrap, also with the Squeak.js, and run it, for instance, in the browser. And he uses that he has a back end in Pharo, for instance, and you can inject code into that image that is running lively in a web browser, for instance. So people use that stuff. It's all open source. And if you, let's say, have the idea to bootstrap an own image and an own Smalltalk system, for instance, you could even say, okay, other Smalltalks at the moment do not follow that, except QEs. I think QEs is now also has the possibility to bootstrap right from the sources and create the fresh image every time, but you could build your own with that one. Everything of that is available. And this visualization that you do now here with that one, it's not the first time that such a thing has been done, because I know that Craig Letter has also done such a thing in the past. He tried to have a minimal squeak image and also tried to visualize this with rectangles to see, okay, which objects are inside, so that he could really have a mini image squeak.
Yeah, I was especially happy with the 3D visualization tools I did, showing not just what bytes are there and what objects are there, but how they're connected, how you can follow all the references. And to look at in a normal image, that's kind of overwhelming. So it was really useful to bring hyperbolic lenses to that visualization also.
Oh,
so
wow.
The objects you really care about are in the foreground larger, and all the other gajillion of them are in the background smaller, and you can fluidly move to different parts of the image in 3D, and that was very useful.
And sorry, Craig, that visualization, was that in JavaScript or with so many objects, or it was in Smalltalk?
Oh yeah, the downside of that is you're only looking at the image at one moment in time. You're not looking at it as it runs, as opposed to some of the other viz tools I did, where you can look at the image as it runs. But yeah, that 3D visualizer is called Walrus, and it was done in Java. And it takes a spanning tree of the reference graph of the image as input. And that spanning tree was generated, from the image that you're looking at, which is cool. But yeah, the OpenGL code was controlled by an app that a friend of mine wrote at the University of British Columbia called Walrus in Java.
Okay. Cool, thank you.
I will share some links on the chat where you can have more information about Bootstrap, or that's what Craig also
yeah,
did.
I can either send a mail at the end if you prefer, or I can or I can. Oh no, you did send them. Sorry.
Someone is interested in that Bootstrap overall. There is on the Pharo Discord server, there's a channel called Bootstrap, where people who work with what is available sometimes exchange on Bootstrap, because it looks like people are interested in building own, for instance, like Eric would like to build own image. As I said, everything is open source, so people could experiment.
I don't know whether Pharo Candle is the last one to check out. That's also a problem, that so many people have been working on it, that you have to know exactly which one did what. So, to recover which parts you have to do, like, is it spelled 1, 2? I don't remember. Where the modifications are, etc. That's a bit of an issue. That's kind of a mess, but that's still really good.
I think for the candle stuff, I think Eric on Bike used to reference it.
Yeah, probably actually. The latest one should be. That's not Karina HP.
I'm sorry, it's Carola HP.
Oh, Carola, thank you. It's been a while. Because the thing about why I'm going back to Karina is also because she did how it's called, a debugger for those kind of, for the process. This one, debugger ST interpreter. This is because actually our PhD a big part of our PhD was focused on how to debug the process of a bootstrap, because it was so complicated before Guichet and our work, that it was very, very hard to get into. Yeah, because you have SPL2. I don't remember which one it is. I think the latest one should be this one. 26th January. That sounds okay. Yeah, that should. I think that's this one, but I'm not certain. Oh no, there's far from Guichet. Yeah, this branch is up to date with Guichet's master. Okay. So I don't know which one is the more recent one. Yeah, everything is staying. Yeah. Anyway, any more questions?
So at the moment,
yeah,
the Polyphemus stuff is slightly broken in that there's been changes to the VM, but could be recovered if there's others that are interested in these sorts of things. It's just a case of like what is likely the kind of thing that's broken, I guess. Is it just like sort of like what's in the Pharo image that you've used to then interpret the oops to put your bit on top? Is it that, or
there are multiple stuff? First one is that they changed something in Spec2. So when you try to open this very small tool that has 4 tabs, it doesn't work anymore. I had to hack the Pharo image to do that. There are object format changes. They added a class variable at some point, or an attribute on meta class. I don't remember. So there are stuff at the language level. What I'm trying to say, in the dependencies, and there is also at the VM level they changed how the memory is represented, how the memory is stored, how the memory is accessed. I didn't go further than that, but there are stuff at every level.
At every level, but not insurmountable. It's just a case of like, okay, so you got to account for these new things.
Porting, It's just that last time I was trying to port that was when I was at Oracle to talk about Graal. I encountered Fabio, for the one that remember, and I tried to show him, and that was fucked up. So I tried to fix that, but so I was trying to work on that for 2-3 hours in my hotel room, and I didn't get it to work. So so that's a bit of work. Maybe a few days, but not that bad. But
are there any tests or anything for the work that is there? So it's just a basic go to look at the tests, and you can kind of figure out like the assumptions, and you just work your way through, don't you?
Yeah.
Apart from the UI stuff is probably
UI stuff is also tested. Part of it is also tested. Yeah. And actually, just because I can give him a small shout out, particularly because I forgot his name, he would. One thing that was done by Cavelion that we didn't incorporate because it was breaking the UI tests, that was a bit of an issue. That was a lot of an issue. Was to implement exactly what Google Maps does and all of us maps applications do, where when you zoom, it only render part of the image, show you that image without any blurriness, and recompute the rest in a thread in the background. So instead of crashing when I was running on a Pharo image, a full-fledged Pharo image with 50 megabytes worth of OOPs, it didn't try to render everything, just the part on which I was focused, and then moved on to other stuff. So that was pretty nice, but it was breaking UI test.
His name is Milton.
Milton.
Yeah.
Is that it? Yeah. Oh yeah, Milton. Yeah. Thank you. It was driving me crazy. Thank you.
So he works on Graal.
Yeah.
So Pierre, I had a question.
Yeah.
So did you ever run Polyphemus on more than one image at a time to do things like comparisons?
No. We wanted to do that, but we didn't get to it. That's one thing that we can do.
Okay.
Yeah, that's one of the ideas that we had.
Right. And did you look at externalizing what you were finding? So it sounds like if you were given a really big image, you basically just ran out of space.
No, sorry. When I say that it crashes on big images, that's a Roissal issue. That's because Roissal cannot handle that many objects. 3000 is fine. Right. You know, you see that works fine. When you get to what's that, 7 megabytes, I don't remember how much that is in OOPs, but that's maybe 2 million OOPs or something like that. Roissal says no, that's too much.
Okay. And another question I had was, how did you come up? How did you choose the name Polyphemus?
Oh, basically we were looking for kind of a blind famous people or some kind, because the thing is that if you are working on the VM and you lose your eyes, you are fucked.
Yeah.
I mean, you cannot do anything. That's impossible to work with. Right. And we thought that Polyphemus was appropriate because when Ulysses passes on his island, he blinds them, and then they cannot really work anymore, and they cannot hoard, I think, goats, if I recall correctly. And yeah, sight is important. But take care of your eyes, basically.
Thank you.
Sure.
Do we have a second part presentation about microdoc? Or?
Sure, yeah, we can take a quick look, at least for a principle of it, because first of all, microdoc allowed me to do this presentation and to take a bit of my working time to prepare it. So we check everything that was working, etc. But as I said earlier, if there is any kind of interest, we can negotiate a contract for me to work on Polyphemus again. I would love that very much because I'm working on Graal at the moment. I'm porting Java VMs, so the Graal Java VM for weird environments, so 32 bits, weird OSs, like some Android kind, Bionic stuff. So I miss Pharo very much, very dearly. Now that I have to work with anything that is Java related, I miss it so much. So please invest in it. So more seriously, yeah, no, what's interesting is just that it's not Pharo. But Microdoc is a company that was founded in 91, apparently. I've been there for about a year now. People are very nice, and that's a pretty great work environment, to be honest. The thing that so this is just yeah, maybe can we put that in? Yeah, okay, that's slightly better. One thing that is important to know about this, that is kind of a crucial point, is that this is mostly software engineers. There are 95%, I think, software engineers. The rest is just basic management, so everything works smoothly. But we don't have commercial people. We don't have anything else. They have 3 main locations. Let's put that there. 3 main locations: one in Berlin, one in Munich, and one in Stuttgart. They work with. They are a member of Data Response Group. I still don't know what it means, to be honest. And that's the leading European supplier for Java and Graal VM runtime and technologies. So that's the thing. Before I started, and before a bit before that, they were developing Java runtime, so Java VMs, Java runtime as well, for environments that are not really supported by general distributions. So particularly for embedded stuff, which always has different constraints. And they've been doing that for more than 20 years. And Graal VM, they've been the first one to port Graal VM to 2 32-bit environments that are used. I think that's said later, but that is particularly used in the trains in Germany. So the way that they plan trains that are going from one place to the other are done by microcontrollers that run Graal VM inside them that we develop. What else that is interesting that we can find here? A leading European supplier of Java in Graal. We have contracts with IBM and Oracle, particularly with Oracle. I was there 3 months ago.
Can I interrupt just for a minute?
Oh, of
when
course.
When you say Java VM, I know what it is. Graal VM, I think I do, but I'm not sure.
Okay.
You can describe.
No, that's a good question. I should have precised this. So Graal VM has been developed since about 2010, 2011, something like that. And their objective was to kind of reboot the JAX Graal VM project, to do it in another way, but basically the same, which was to develop a Java virtual machine in Java itself. So they went back to Slang, basically stuff like Slang, like AirPython, for the ones you know, that did the same thing. That was done also in Self. That's what we've done in Smalltalk since Squeak, I think. Actually, the first metacircular VM was a Blue Book, but that's another thing.
So the Graal VM is written in Java. Is that what you say? Okay, brilliant.
Yeah, and basically what they tried to do with Graal was to do that VM, that Java VM, and from that they did some polyglot stuff. That's what Fabio did, for the one that knows him. That he works at Oracle now, actually, and he was particularly to give you one specific example. Fabio was dealing with objects from Python, Ruby, and Smalltalk at the same time, and exchanging data between the environment to be able to perform operation within different environments. So that was a pretty cool demonstration. And the next thing that they tried to do with Graal was to develop images. So they take your Java code and compile everything to binary and put that in a binary environment and run it. So instead of loading every class, initializing every class like you would do on the classic Java VM, it's more like we do in Pharo, because you create an image and you just run everything directly when you start it. You don't have an initiation phase, you just start. And that's very useful. That's why I was saying that it was trendy. That's actually kind of thanks to Graal, among other things. Because Graal VM reinvented basically the concept of images, and that got very trendy for microservices. There are 3 main libraries actually for doing REST microservices in Graal VM at this moment, as far as I know, or 4, I don't know. But that's why that's basically what Graal is. This is just a new implementation of a Java VM that is supposed to be kind of metacircular. Is that okay? Did I answer your question?
Yes. Yeah, brilliant. Thank you.
So you can think of Graal VM as a kind of third level or third generation of Java VMs, because initially they had, Java had an interpreter initially. Later there was a JIT. Also, Smalltalkers were involved in that, in building, for instance, the hotspot VM at Sun back then. And now, let's say, what is applied on this Graal VM is ahead of time compiling.
Yeah.
So basically, you do not JIT the method into a native method, but basically you already compile it to the native thing, and then you build an image with the native thing from the heap. And then let's say you have a quick setup or a quick startup. So you do not have a warm-up phase for the VM. And this is really very nice when you, for instance, run with the VM on, for instance, a cloud or somewhere where you do not have, you instantly can start, or you instantly have the speed. Performance.
Exactly. You run, basically, you don't have any initiation phase of warm-up phase, and therefore your program starts directly. So if you have microservices, so very small program that execute for a very short time, that makes a lot of sense.
And then I guess the other big advantage is that you can have a Python object and a Java object both live in.
No, I kind of made that sort of mix, but these are 2 different projects.
Oh, right. Okay. Sorry.
Yeah. No, but they cannot mix that much stuff. And if you are interested a little bit more in this, one of the limitation of Graal VM is that everything is compiled to binary and therefore doesn't change after that point, right? The image is static. The image that is generated is static. and you cannot modify it at all, and that means that you don't have reflection. They break reflection. If you have reflection anywhere in your code, it will get slower, a lot slower, because assumptions are broken, and you cannot optimize the code as much as you would without reflection.
And also, it's not multi-platform, so you have to compile to
exactly
like a C code. No,
that's binary. You are back to the binary issues. But you will get more abstraction and stuff like that. So that's the trade-off that you want to do. Whatever.
Is there any overlap with WebAssembly?
Not as far as I know.
Okay.
I
wouldn't be surprised if there was. I just don't know about it.
If I can pitch in here, so from what I understand, the guys in Argentina were doing the B Smalltalk. It's pretty much on the same lines that GraalVM. So they have the whole virtual machine written in Smalltalk and generating machine code, and you also start up very quickly because it's all there. And you have a separate stage. If now it's only one platform, but you have a separate stage where you have to compile the VM in a way. So generated the machine code ahead of time, which is in a similar way that as the jitter does during a regular. So it's similar.
Yeah. So just pursuing this image fantasy land stuff.
Yes.
I'm doing a lot of work now with tabular data in memory, and there's a project called Arrow. What Arrow has done is come up with a common memory layout that can be used by any kind of tabular API, whether it's C or anything else. So what they've effectively done is to separate out the essential tabular data into a memory space that you can then operate on using different languages. Now, I wondered, has there been any thought given to there being a kind of a similar thing for object memory?
Yes.
Obviously, right, okay.
Yeah, we did think about that. It's just actually just doing all of this work. I mean, not in Graal, right? You mean more in general about Polyphemus, I think.
Well, not necessarily. What I was thinking was if there's a common layout of memory for objects, you just say, well, look, here's a header, here's a byte, so where we go. And each in the header, it will say, oh, my class is implemented in Smalltalk. And the next thing down would say, well, my class is implemented in Java. But the object memory is shared between them all. It sounds kind of slightly crazy, but...
No, actually, that's not crazy, at least not to me. To be honest, one of the things that when I stopped my PhD, I tried to move on away from Polyphemus for a bit, and I was starting to re-implementing Smalltalk VM from scratch in C++, I think, at the time. And the thing that I wanted to do actually was to prove to a friend that Smalltalk, Lisp, and Forth were the same language. From a concept point of view, these are exactly the same language. It's just that we represent them in a different way, and that doesn't matter. And I had an existential crisis even on programming languages, because programming language, we talk about programming languages in a very weird manner, is in the fact that everyone knows what a programming language is, but you cannot really define what it is either, because you have different kind of granularity and stuff, and actually what we say about Lisp, and I mean Lisp, Forth, and Smalltalk are basically three different ways of representing the same thing. You do the same kind of operation, and that's weird to me.
But I think that what Bruce was asking is more at the binary representation of the object in memory.
Oh, sorry, yes. That's why I was bringing that up. Thank you. Sorry, I get mixed up sometimes. I was bringing that up because the way that I wanted to prove to her that that was exactly the same three languages was by having multiple objects and multiple runtimes in the same memory space. I wanted to be able to share, to have some OOPs that were language independent, that could do operation for any kind of OOPs, and have Forth OOPs and have Smalltalk OOPs interact within that VM, within that same memory space.
But for example, there so in Smalltalk you have immediate objects like the small integers by tagging one bit. I think that Python doesn't have that, so the integers are.
This is implementation dependent.
Well, but if we're talking about how
if you talk about
we could share
CPython, yes, they don't.
Yes.
So not as far as I remember, at least. But if you talk about the AirPython, so PyVM, yes, they do.
They do what? Have the tag?
Yeah, the tag integer, yes.
Ah.
Or at least they did an experiment on it at some point. I'm sure I read something about this.
I think that if you have a list of integers in Python, then each integer goes to a different, it has its objects header and it goes to a different memory location, which is very inefficient.
Yeah, but that's Python. That's what they want. They want inefficiency, so yeah.
Well, they got the efficiency elsewhere by implementing other things in C.
Yeah, sort of. I mean, the way they talk about it, like, I don't know if you know, but there is no just-in-time compiler in Python, in CPython specifically. Because they said, no, we prefer to keep our VM simple enough, so we will not implement a JIT. That was explicit. They don't care about efficiency because the main purpose that they see, again, as CPython, was not performance important. And still you have Python VM that implement JITs, such as StraightSkin, if I remember correctly, or PyPy, actually. Because for them, that matters more. And that's an experience.
But for example, the Smalltalk with its purity is have everything is an object, the order collection is an object, you can put a breakpoint in collection add. In Python, the list is implemented in C, and the other is in C, and so that's where the efficiency that they lose in the interpreter, then they will gain it when
kind of.
The question is where you want to blend in from the level. Would you like to blend in from the VM level? I mean, for sure, when you have, let's say, a C program, you cannot say, okay, I have an object header and the integer there is a different one than, for instance, in Smalltalk, where it's really a deal with a trig as being like an object. Or if you would like to do that on the language level. For instance, there was a project back then, I remember from Ibas Rengli, which was called Helvetia or something, where you could blend in other languages inside of, for instance, Pharo. This was done in Pharo 1 or 2. Where you basically had the grammars and you could even mix the languages. So you could write a test, a Smalltalk test combined with whatever, or some similar to what you have in C# that you have LinQ or other, where you can write SQL. You could even write an SQL inside of a Smalltalk or embed it. So you embed other languages inside of a host language like Smalltalk without breaking tools. That was, I think, the idea back then. And use all of them together in the same tooling.
Yep.
So this could be done on different levels. And there's this work that was mentioned now also from Fabio. For instance, he has this Kral squeak, where, for instance, you could use squeak to call Python and vice versa and other things to have that polyglot things.
Yeah. To add on that and to give you a more recent example, Pharo added, like in Pharo 7 or 8, something like that, traits, and the implementation doesn't touch the VM at all. You know, so that's kind of a difference as well. If you want, that's a selective kind of efficiency, but that's also because sometimes they don't want to expose some stuff for security or just because that's what they did initially and didn't change it. The way that the VM works in Pharo is really to just take copies and do stuff with them. There is a few primitives, maybe 500, which because there are declinations of that primitives, but there are pretty much a few, and that's about it. With that, you do everything. And the point of Smalltalk is to do everything that you can at the language level, so it's more workable by the developers that use the system. That's how I understand it, at least. And that's the thing that I'm trying to do with Polyphemus as well, is to give the power to the developer that works with this all the time, but just is limited by the way the things are done. And I want to provide the part that isn't doable at the image level in a different manner, that is still Pharo level kind of, you know. So yeah, that's about how you do things and what you want to expose, basically.
Thank you.
Ever thought about using Polyphemus to visualize, for instance, Java bytecodes and house?
Sorry, I didn't catch that last part.
Use, for instance, the tooling that you have now to visualize the Pharo images, but to use, for instance, to visualize the Java images.
Yes, I wanted to do that. I want to. I need time and money. But yeah, I thought about it, of course. Wanted to do it for C as well, for Python, to try to grab some more attention, but times.
Trying to do it with C managed memory would be a bit crazy, wouldn't it? Because it's just completely once the compiler's finished, it's just a pool of mush.
Yeah, I know, but I mean, you are talking with someone who finds memory corruption fun.
Okay.
You know, I know that's crazy, but it's just that I realized at some point that I didn't know C at all, in the sense that yeah, there is a main, but actually there is a runtime for C. It's just that we never talk about the C runtime unless you are talking about very low level stuff. And for me, that was weird. I want to know about the C runtime. So yeah, I'm a bit weird. That's to recap. Okay. Any other question? Let's assume no then. I will quickly finish presenting MicroDoc, at least because they allowed me to talk about Polyphemus, which is also always nice for me. So yeah, what I was going to say, yeah, one thing that they do with GraalVM particularly is to sell licenses for embedded stuff that control automotive edge units and stuff like that, e-charging station, credit card terminals, so wide range of devices, supporting 32-bit and 64-bit architecture for different kind of operating system. Yocto QNX, I haven't seen them in our code base, but I'm sure they are somewhere. So weird stuff that I don't even know about. They're a member of the Java committee procedure or something, executive committee. So basically what they want to do with Java in the next iteration, we are part of that. We talk about it with them. Member of the GraalVM advisory board. That's what I was doing in Zurich a few months back. I was there to talk with them about the future of GraalVM. So that's the kind of stuff that we do with MicroDoc. What do they do? That's a bit dense. I needed to rework those slides, but that's very dense. I don't know. That's basically the same thing for me. Just for other devices, yeah, they do. So basically, the way that we work is that we have a lot of knowledge and people with a lot of knowledge in the company. There are a few small talkers, actually, ex-small talkers, because they had to move on. And some people that do electronic stuff, more electronic stuff. So we talked about software first, electronic there. That's what they did for, this is a device for homes in Germany to check the electricity network, I think. Smart grids. So basically to give electricity to homes that needed more at some points. This is for the largest energy supply company in Germany and Europe. What else? Providing customized IDE. So that's pretty badass for me. Code review, technology employed, Java, JavaScript. Yeah, so basically we know a lot of stuff, about a lot of different domains. Fleet management. Oh, cool. So to be able to organize 3,000 trucks. Ooh, damn. I needed to read those things before. And full stack services, yes, they work on cloud infrastructure a lot, framework, application development, and as I said earlier, virtual machine technology, such as Java and GraalVM runtimes. But basically, they know, I mean, yeah, that's basically. But basically, the guy that I'm working the most with, that is Dr. Koufair, I don't even remember the last name because I work with him too much. That guy knows everything about low level. I'm always, anytime I'm bored, I just ask him anything stupid about how low level works, and he can explain everything. That's crazy. I don't know how he does this. So yeah, they have a lot of knowledge, and I hope that I will help them there. And if with your help, we might have some more knowledge about small talk stuff, basically. So yeah, just to present it a little bit, at least. Yeah. Okay, so this is all stuff that I missed. Okay.
So GraalVM is open source.
Yes.
But Microdoc sells licenses.
Yeah, and actually Oracle does as well. The way GraalVM works is that there is a community edition that is open source, and an enterprise edition that is that you have to pay for. The way we work is to provide support for the community edition, and we have multiple ports in enterprise edition, so the paying part that is with agreement with Oracle for 32 bits platforms. So we provide basically support or products.
So are you saying something like the community edition can open a few sockets, or is it only 32 bits and the other is the professional or whatever you have to pay?
Yeah.
Plus everything enabled in the binaries are okay.
Exactly. For instance, one of the main selling points is that the enterprise edition has the G1 GC, as they call it, which is a very efficient garbage collector. And if you are working on the community edition, you are stuck with a serialized GC. So one thread.
Okay.
There has been some work for a parallelized GC, but for now, this is not that. So yeah. They still sell licenses for, I don't know if they sell licenses or just support. But the thing is that Graal is a huge code base also, and they do not support many OSs. Basically, they kind of, they provide the main stuff, the main bulk, and then you have to make the little bit more to make it work for certain OSs, right? So it will not work for every OS that you have at work.
And in the Graal open source GitHub, who's the main contributor? Is it people from Microdoc or someone?
No, this is Oracle people. We are 4 in the VM team.
All right.
And with 3 people before I got there, they were able to port to 32-bit architecture, which was, well, I heard the stories and that was pretty impressive to me, at least.
Nice, thank you.
Okay. Anything else? I guess not. So Gio, either we can stop now because I think that's time, a little bit more actually, or we can do some pair programming if some people want to. I mean, my girlfriend is at the bar drinking, so I have some time tonight. I don't mind.
Thank you.
Yeah, thanks a lot.
I think I recall Giovanni saying that he had to go off to entertain the babysitter.
Sorry? Oh no, I don't have a babysitter. I'm the babysitter.
No,
I don't know where my big
Giovanni,
fat dog is there. Oh, sorry, yes.
Yeah, Giovanni said
right,
he had to go off to entertain his babysitter.
That's true. I forgot. Okay, let's see if that works. Yeah. So I guess, well, does anyone want to continue?
I would like to, yes.
Sure.
Yeah. Well, we can until my girlfriend comes on. At least I'm available. So there, I was in the meantime of knowing what we were going to do next. I was trying to open a Pharo 11 image. I think that's about 40 seconds to open, so we will see whether that still works. That's a pretty old one because I didn't change it for a while, but.
So you're trying to open a small image or what?
No,
like
a full-fledged one. Like the image that you download from Pharo Launcher.
How big is that image?
If I recall correctly, that's about 56 megabytes. Something like that. So images, Polyphemus. I don't remember. Did I download it there? Yes. So a clean images is 63 megabytes.
Thank you.
In comparison, the minimal one is, it's actually 13 megabytes. I didn't remember. And the Candle one is 200 kilobytes. I was way off.
So the Candle doesn't have the compiler or anything like that. It's just what can you do there? 3 plus 4.
Yeah, 3 plus 4 should work. Basically, I think you can do the way it was intended was to really have the minimal kind of runtime. So what you would have in Forth or stuff like that implements really the minimal amount of features. So probably some integer management, so comparison, every mathematical operation that you have, Boolean logic also. Because again, microcontrollers, so Boolean and integer are pretty much what you have to work with. So this is not meant to work with to re-implement Excel or PowerPoint. These really are the basic bricks that you need to build software upon. Hey, that works. Okay, how much objects are there? 100,000. Yeah, that's about 1 million objects there.
And what you said before is that that's a clean Pharo image, but if you get a production image that has grown a lot, then you cannot visualize it. It can be read, but not visualized with this.
No, you can visualize it. It will just take time.
I thought you said that something about Rosal not handling so many objects.
Well, it does handle them, just not well. That's the problem. It just at some point it's just a lot of work to do for Rosal, and it takes time. Like you saw, it took about 40 seconds to a minute to open that million objects. So if you have more, I already had 20-30 gigabytes of images at some point during my research, and that should work. It will just take maybe 2-3 days. And the next render will be in 2 more 3 days. So that's why we had Milton implemented that scheme to load only part of the image. And for us again, like the thing that Craig, I think that was Craig that said that earlier about implementing a 3D visualization in Java. That was pretty cool, but the visualization that I show here is really stupid. I mean, that was just a use case for us to try to implement a visualization for our memory with very little knowledge, basically. You did with our abstraction, you didn't need much knowledge about the VM to build that. That was our point. Because to be fair, I do not know how to do interfaces in general. So that's the most UI I did in maybe 10 years, right? And I would love to see to do that with to do a 3D one of that, but it's just that it's about knowledge again.
Yeah,
For
so
us,
I
that
want to
would-
add. Oh, sorry.
Yeah, go, please.
I want to add that the Walrus implementation
Mhm.
was from 2006, way
Yeah.
before I even got into any web tech at all. And now, of course, I'm working in Squeak.js, where everything on the web is available, and there are tons of JS APIs for doing hyperbolic visualization and stuff. So it would be really fun to revamp that as a web app.
Oh yeah, that would be cool. That would be cool.
Want to do it in Pharo? There's also a 3D engine in Pharo called Wooden.
Yeah.
So
With by Ronnie. Yeah.
Yeah.
He was my roommate for a while.
Ah, okay.
I know Ronnie pretty well.
In these visualizations, you put a lot of regular objects, which all seem to be the same size, but they are not, are they? I mean,
no. In that case, there is no scaling at all. Sorry. There is no scaling at all, but we could put that, as I put on the presentation, by asking for a box OP byte size, I think. Yes. Ah, crap. I didn't implement that UI enough, so I cannot choose the autocomplete. So if I ask for the OP byte size, rs box, no, this is not a box, this is a box OP. Yeah. No. What did I put in that? Models, yeah, that's model. I think that I had an autocomplete at some point, but just forgot. And this is scaling that should work. Testing statistic, yes.
what is it you're changing there? Scaling?
So this, the way that we saw it was to try to have a few amount of queries that we could try to work onto the visualization. Particularly, this one should work better. At least I would remember how much it worked. For example, I want to see only OOPs that have 0 slots. Why not, right? Number of, I can ask that number of slots. Does that work? No. Of course, because I don't remember my API at all. Sorry. Abstract, accessing slots. OP number of slots. Yeah. So I need a Boolean. For example, I'm trying to select stuff, so I need a Boolean to validate that. And these are all of the OOPs that need 0 slots, that have 0 slots. So if I click on this one, I can inspect it, and it has elements apparently because this is a 64-bit indexable. Oh, that's very member set actually.
What is an EOP with 0 slots? It has no instance variables, basically.
Yes, exactly. So if you want to simple one, you have nil object. Nil object doesn't have any slots.
Yeah, but there's only one of that.
Yeah, but there's also false and true.
Yeah, but you have plenty
and there are
more there.
others. Yes, but 0 slots may mean that they are indexed. Sorry.
All the arrays have 0 slots because they have many slots actually. But
exactly that's actually exactly one point that I was trying to point out during the presentation. The thing is that you have to decide the new semantic of words there, because you are neither in the language nor in the VM, and therefore what is a slot? If you ask the VM, a slot is 64 more bits at the end of the object. That's it. That can be anything in it. If you ask Pharo, that's an attribute, an instance variable, right? And therefore you have to decide a new kind of semantic for this too. This is a bit weird to work with, and we ended up deciding that the slots were OPs. So we took more a VM level approach to it, but we thought that indexed elements were not slots in themselves. I mean, At least not 8-bit indexable and stuff like that. I want to check whether I have this. Because we have a lot of testing stuff. Do we have this is indexed? No. We are okay. No. Yeah, I could add it actually. It doesn't matter too much. Yeah, actually, it's just very simple to add. And OP-bit indexable, yes. That's true. So if we want to improve our condition,
so is your job title Graal Virtual Machine engineer?
Yeah, it's mostly software engineer.
Okay,
but I'm working mainly on Graal.
But you don't work in Germany, do you?
No, I work fully remotely. And I go there once a year for a week, basically. Okay, so there we see this one that has 0 slots. That is an instance of Pharo candle array, but apparently that has nothing in it. Indexable without slots, yeah. See? So that was a way to the thing is that we didn't have any way to manipulate that memory initially. And then I did a memory scripter where I can just ask for all of the objects. So this is an old API again. Yeah. And there I have a list of the 3,000 something like that subjects, 2,473. And one other thing actually that doesn't really show in the presentation, because how do you show that in the presentation, is that you can just navigate also through your object graph, which you cannot really do at the VM level. So let's take, for instance, yeah, sequenceable collection. No, these are the class table. Take that, yeah. So I can go onto my class table page. You can see actually this one that shouldn't be very filled. Well, you have 55 entries. Actually, we even removed the entries that are not used because we wanted to see some stuff. And in the other one, there actually are classes too. More interestingly, there are 153 indexes taken instead of
that's something I don't understand. So you showed that there was a big class table. And
yes,
what is that? Yeah.
So the class table. Actually, one of the things of Polyphemus was about trying to improve on the experience of new people that were working on the VM. So if I go back to, I will just refresh that to try to explain that better, because now we have tools to explain also. So this is better. Okay, there. So as I said earlier, there are 5 special objects. Yeah. In the special object, you have the class table should be this one. No, this is the class table page. This one. Okay. The class table is a VM level OOP that has a few special properties, and particularly it holds every it holds a few class table pages, and those class table pages hold references to classes. So for instance, I have a class species more integer here, which has a superclass, method dx, format, name, and instance variable, and class variables. To give you to tell you that in another manner that surprises us a lot, if an OOP is not in the class table, accessible through the class table, it's not a class. From the VM perspective, that's how they check that something is a class.
So every time you compile or you add a new class, you need to add a new
entry there.
Entry in this.
Exactly. In an available entry in the class table page. Yeah. Because otherwise this is not a class. So it doesn't matter to a VM as a class, at least.
So that table is not an order collection where you can keep adding things. It's a table.
That's a small talk OOP. So this is an indexable without slots, apparently. So that means a 64-bit indexable, if I recall correctly. So these are just addresses. These are just OOP. This is just like any other object, except that you cannot access it at the language level by any manner that I know of. This is not referenced in anything. Actually, that's one thing that we can check if you want for fun. At least within, well, we can try to do it after. But like, for example, that's a kind of tool that we could have. We want to check that for all of the objects in the memory, we want to select the ones. So an OP. An OP all slots. Yeah.
Excuse me, Pierre. Sorry to interrupt. Just say thank you. I've got to zoom off.
Okay, sure.
Very interesting presentation. So thank you very much indeed.
Thank you. Have a nice evening.
Bye for now.
Bye-bye.
And I want to... an image has loads of classes, and each class is a big object, and that's why you have a big chunk of memory used by the classes.
Yeah.
Yeah.
Basically, the thing is that since there was a nice blog post by Elliot, I mean, that's Elliot, so that's still a bit hard to read, but when you get into it, you can, that's pretty nice. That was explaining how he viewed the limitation of a Smalltalk image about the number of classes and how he wanted to resolve it. And that's the solution that he chose. He chose to provide enough space for 4 million classes or something. I think 4,000 times 1,000, so that should be that. So that people have a lot of space to work with, basically. So that was the decision by Elliot to do that like this. Did that answer?
Yeah, sorry, no, we have a small home accident here. No problem.
Okay. Yeah. Whatever. So that snippet of code is pretty classical for us stuff. I want to iterate over all of the objects that I have. And for each object, I want to check whether in any slot of this OOP, there is a slot that references the class table. Actually, that
and so any object will be referenced in its class, and it would be an entry to that class table, wouldn't it? Or
yeah, but that's not transitive there. What I'm asking for is that is there coming back to the graph. I have too many stuff. Sorry. Is there any object in the memory that points to this object there? That's what I'm asking. Not transitively, directly.
So that's the special object array, the one that you're chasing.
This one is the class table.
No, but the pink ones.
Yeah.
Okay.
The special object array is actually not a special object considered by the VM. It's known, but not. This is not the 51. This is not a hidden one. That's all 60. There. This is right after the hidden objects. So again, this is still bugged. So you have a special object array there that is on the side, on the bottom. But actually, you have a partially filled special object array there on the top. It's just missing some slot, I think. Like 12. 12 is nil object, 12 is an object, yes. 44, I don't know. Yes, 44, yeah. 43 is nil, no. Still nothing. Yeah, you have the end of the, yeah. For example, class trap 4, unused byte code. So yeah, this is a partially filled special vector. But that's another VM level entity, is what I'm trying to say. And even this one doesn't point toward the class table here. I mean, we will see, actually. Yes, understand our slots. It's been a while. So in that case, I have a nil object. Okay, but that should still be able to answer our slots. Hierarchy, actually. Accessing slots or verified slots. Oh, I don't have access to the slots. Okay, fair enough. Verified slots. And therefore we can go through there. Okay, because I said yeah. And that should say to true. To do that properly. Yes. Yeah. Okay. That looks good. And apparently there is no object like that points toward the class table. But that was expected, so maybe something that at least would give us a result that we may interpret correctly. And to check whether that piece of code is fine and whether the Polyphemus is fine, are there some slots somewhere that points toward the verified metaclass? That would have made sense to me. Okay, neither. That's worrying for me. I'm losing what else could we try for string class, verified string class maybe? Which one is it?
I just realized that I might be the only co-host here, and I'm gonna stop the recording.
Sure.
I think we should have done this before.
Yeah, kind of more of a discussion. Yeah, sure.